Hello, this video will introduce the Multiphysics Boxer MPB10 from SICK. This sensor attaches directly to a machine, motor, or pump or gearbox, and it directly measures temperature, vibration, and shock. This information is used to extend the life of a machine, extend the machine's availability to operate and do its job, and it helps reduce maintenance costs and increases production quality. Generally, there are three levels of maturity of service levels. Reactive maintenance, so when things break, we fix it, and things are down during that time. Moving into preventative maintenance, where you can assume when things will break and replace it and fix it ahead of time. You're still offline, and it might cost more than it needs to if you're replacing parts prematurely. Then we can move to condition monitor and predictive maintenance. Here we're using some historical data and live data and trends to extend the service life of the machine and service parts and keep the machine online and producing as much as possible. So how does the sensor do these things and acquire this data? We're evaluating temperature as well as shock and vibration on 3 axes. We're taking these key values and we're measuring and storing those and then transmitting those key values. This data will indicate when and how physical anomalies occur and trigger the user to take action. We look at shock and vibration in both a time domain and a frequency domain. Each tells us a different story using onboard, on the sensor, statistical analysis, typical for condition monitoring. While the Multiphysics box is very powerful and advanced vibration analysis tools that people familiar with vibration analysis can use, it can also be very simple and powerful use for anyone and anywhere. Events evaluated in the time domain tell us when and how severe abnormal events were, what happened. ARMS is the average acceleration, and that can tell us about higher frequency events caused by, let's say, bearings and gears. VRMS are lower frequency events in the velocity, we're looking at that might point to imbalances, wobbles, or misalignments. At the same time that's happening, the MPB is also collecting and evaluating key factors in the frequency domain. What looks like vibration or noise to us is actually made up of different frequencies and different amplitudes. The Multiphysics box can break down those blocks of vibration noise and point to dominant and harmonic frequencies that can point to what's happening inside the motor, drive, or pump. Tracking these signals over time can give us pre-failure warnings. So how do we know what to do with this data? What does it say about our motor, gears, bearings? We can start by looking at this ISO standard. This gives us some absolute values to look for, but the Multiphysics box also uses this standard as a relative measurement for teaching in particular motor and seeing how much change is still good and when we're starting to enter a restricted operation and when damage may occur and trigger a warning or alert. What are some applications and examples where condition monitoring is very valuable? We see them a lot on conveyors, on the drives, the gears, the rollers, and even on slide beds. In the milling and grinding of food for consumer goods markets, and also cooling fans in just general factory automation and machine building. So here's an example of a pump for granulates and pellet transportation, but it also looks a lot like pumps for coolants and for cutting and milling processes. Here's a conveyor with a roller, motor, gearbox monitoring going on. It's looking for shock and changes in vibration and temperature. And in this last example, we're showing an industrial fan, monitoring for over temperature as well as imbalance due to damaged blades or worn bearings. And that kind of wraps up what the Multiphysics box is about, what it monitors, what it looks for, and examples of applications. Next, we can do some hands-on setup and demonstrations of how the sensor works.